Good evening. So, is my camera working properly? Hello, Tanish. Is my voice audible? Okay, you can also unmute yourself. Shall we start our class or shall we wait? Okay, got it. Okay, no problem, Tanish. Hope my screen is visible. Respond in chat. So, so let's start. Those who have not joined, they can watch the recording later. Okay, shall we start? Please respond in chat. Okay. So, have you done your homework? Okay, you can send me later in the WhatsApp group. So, proceeding further, we have completed limits and we will be doing the previous year questions of limits and as well as continuity and differentiability together. So, first, let us proceed our syllabus in the chapter about continuous functions. So as we were talking about the functions later earlier on, and we were discussing about the limits of the function. So now we are going to talk about the continuity of a function, which is a property of a function which tells us that the function is continuous or not. Continuous is very simple, like layman language, we can think of it as the curve is continuous whenever we wherever we are concerned about the curve, right? For say from a for a period or for a point. Okay, so this is about continuity of a function. So let's refer to the bookish language and bookish definition of continuous function. The word continuous means without any break or gap. If the graph of a function has no break or gap or jump, then it is said to be continuous. A function which is not continuous is called a discontinuous function. While studying graphs of functions, we see that graphs of functions, sin x, x cos x, exponential functions, etc., are continuous, but reciprocal function has a break at x is equals to 0. So it is not continuous at x is equals to 0. And as we have earlier discussed about that why the function 1 by x is not like definable, or it does not exist at x is equals to 0, because it forms an indeterminate form, right? So similarly, tan x, cot x, secant x, etc. are also discontinuous function at times. So here in the example, we have seen that this is the function of sin x. This is the curve of sin x. And here we can see the curve is going through continuously. And that's why it is referred as a continuous function. So any doubts? And doubt, you can unmute yourself and you can respond, please. I'm waiting. Please respond. Is that clear or not? Okay.
Yes, sir.
Okay. What is the doubt, Tanish?
So no doubt, sir.
What?
No doubt, sir.
No doubt. Okay. So एक बार मैं let me repeat once also that continuous function, we are calling a function continuous when the graph or the curve of a function is flowing continuously without any break or gap or without any jump. So when it is continuous, when the curve and the graph of the function is continuous, then we are calling it as a continuous function. And we will be studying further about its mathematical definition, how I can check a function is continuous or not. Let's move on. So continuity at a point, continuity in an interval, and we are also going to discuss in intervals also about closed interval or in open interval. So first, let us talk about continuity of a function at a point. So a function is said to be continuous at x is equal to a if limit of that function is equals to a. And whenever, as we have talked earlier, that whenever we are talking about the limit of a function, then we consider and approach that function at that particular point from left hand side and right hand side, and that we call it left hand limit and right hand limit. So when left hand limit and right hand limit, so this is the left hand limit and this is right hand limit, comes out to be the equal to the value of function, then the particular function at that point will be defined as continuous at that point. Okay, so this is about continuity at a point for a particular curve or for a function where we are finding left hand limit and then right hand limit and the value function where we are just substituting the x with the given point. So this is known as value function. Okay, so is that clear, everyone? You can unmute yourself, please say.
Yes, sir.
Yes, please say loudly. Okay, so moving on, let us discuss the continuity of function in interval. So a function is said to be continuous in closed interval. First of all, let me define that what are intervals. So interval is like a period of points on a number line. We can consider this as on a like number line interval plus infinity. There are 2 points, say they are A and B. If we are including all the points between A and B, but not A and B, then we will call it as open interval. Okay, open interval. Okay, when we are not including the point A and B, then we are calling it as open interval, and we will represent this as in brackets, small brackets AB. Okay, and when we will be including, like when we are excluding it, so we will also represent there are two dots, and we are taking all the points between them. And these nodes represent that we are excluding the point A and B. This is minus infinity to plus infinity. This is a number line. There are the same points A and B. When we will be taking each and every point between A and B, like all the points, and as well as we will be including A and B, then this particular interval will be known as closed interval. And it will be represented by big brackets or square brackets, and we will write it as in this form. So is this clear to everyone, the concept of interval? Please respond. I'm waiting. Am I even audible? And is my screen visible? Come on, everyone. Please unmute yourself and respond. If there is any doubt, you can unmute yourself and ask. So I guess there's not any doubts. Okay, so let's proceed further. We have discussed about the continuity of a function at a point. We have discussed about the continuity of a function in interval. And so, and we have discussed about the continuity, but we have discussed about the interval. So a function y is equals to fx is said to be continuous in a closed interval if the limit of the function approaching from right hand side, that we have mentioned it as a positive, like a positive equals to the value of function, and the limit of function which is where is c, where c is a point belonging in a b open interval, means c can be any point between a and b. So the limit of function at point c is equal to the value of function. And whenever we are writing a limit of a particular function at some point c, then we will be discussing about both left hand limit and right hand limit in this particular case. Okay, so this is one condition that we have to here we have a closed interval, so we will be taking the context of this particular case. Laptop stock. No. So for closed interval, we have to for closed interval, we are approaching the value of a from right hand side and the value of b from left hand side, and both those limits must be equal to the value of function. Okay, value of function at that particular point, like for at this instance for a, and at this instance the value of function for b. So these are three conditions. When these three conditions will satisfy, then we can say that our function is continuous in closed interval a b. So is that clear, everyone? And even if it is not clear, even if you want me to go back and start from the start, then I can do that also. but I want your respond continuously. Okay. Please unmute yourself. Continuity in an open interval AB is, here C is every point in AB open interval. Okay, so we have to find it here, left hand limit and right hand limit must be equal to the value of function. Okay. What is the problem? Are you unable to unmute yourself? Please write in chat if it is a case. Is anyone there? Is my voice audible? The screenshot. What is the issue?
Yes, sir. Yes, sir.
What, yes, sir?
Sir, your audio is visible, but actually, the reason why I'm not answering, sir, I'm actually in traffic, sir. So that's why I don't want to disturb the class with the traffic sound. So that's why I didn't turn on in the mic, sir.
What are you doing?
Right now, I'm in the traffic, sir. I actually going to my room. I just finished my college and going to my room.
Okay. What about Tanish? He is outside. He's in outdoors. Okay, but you have to respond so that I feel that everything is going well. My screen is visible. My audio is
Yes,
going.
sir. Yes, sir. Your screen is visible, sir. All is well, sir.
Okay, okay. So continue the class. So we were discussing about the continuity of the function, and let's focus on we have talked about the continuity of a function at a particular point, and we were discussing earlier about the continuity of a function in an interval. So okay, so we were discussing also about continuity in an interval. So that is similar, but we only have to understand that whenever we are discussing about closed interval, we have to see first of all the function must be continuous for at every point in the open interval between A and B, and the additional conditions which must be true for the closed interval is these two conditions which is 1 and 3, where we are approaching the function and the initial value of a from right hand side, we have to check only the right hand limit on a, and it should be equal to the value of function on a. And it is the same case with b, just we are approaching point b from left hand side because of a reason, because from left hand side we will be approaching, because this is our zone, this is our interval. If we will be approaching b from right hand side, then here these points will not be coming in our interval. Okay, so this is the reason
Yes, sir.
behind plus and minus. Okay, so let's move ahead. So this is some statement. If y is equals to fx and y is equals to gx are continuous function at x is equals to a, if these two both of these two functions are continuous at a given point, then functions, when these two functions will be operated by the operations addition, subtraction, multiplication, and even division, then their product or their resultant will also be a continuous function at x is equals to a, provided that in the case of division, the g of a, that the value of function of the second function, which will be in the denominator, should not be equal to 0, as if it will be so, then it will be coming out to be a indeterminate form. So this is the condition for that, and the condition is same. Let me repeat it. If there are two functions like f and g, and if they both are continuous, at x is equals to a. So if they are continuous, then if these two functions are getting added, then the resultant function will also be continuous at x is equals to a. If these are getting subtracted, then it will be the same case. If they are getting multiplied, then their product will also be continuous at x is equal to a. If they are getting divided, then they are also going to be continuous at x is equals to a, provided that in this case g value of function here do not become 0. As if it will become so, then our function, the value of the function will not remain finite. Okay, so as we are discussing about continuity of a function, let me repeat how a function will become continuous. Let me give you the raw feel of continuous function. Okay, so let's take an example of modulus x minus 1. Let's say this is our function. Okay, and if it is our function, then first we have to draw the graph. At x is equals to 1, the y will be 0. So if it is 1, so our function will be lying here. And as we know, bad one, right? Somewhat this will be the curve, this will be the graph of the function. So here we can see that the function is continuous. At 1 also it is also continuous because the function is lying and the function exists on x is equals to 1. So here if we have to check about the continuity of a function, what we have to find, that we have to find left hand limit and right hand limit. As we have done it earlier also, this is the same like finding the existence of a limit, and it should be equal to the value of function. Value of function what? Here in this case, as we are checking at x is equals to 1, so we'll be checking for limit of function. It must be equals to f of 1, and x will be tending to 1, and here we have to further check for left hand limit and right hand limit. Okay, shall we do it? Let's do it. So our function is, and first find out left hand limit, modulus x minus 1, limit x tending to 1 negative. So 1 negative is similar to 1 minus h. So 1 minus h minus 1, and h tends to 0 because we have discussed earlier that the value of h is approximately 0 because as it tends towards the value of 0, either from plus infinity or minus infinity. So solving it further will become 1 minus 1, 0 minus h, h tending to 0. So it is minus h, comes out to be h, and we know h is tending to 0, so we can substitute the value of h with 0. So left hand limit is 0. Finding right hand limit our function is this. We are going from plus infinity to 1. So sorry for my bad handwriting. If you're not able to understand it, please say out so that I'll correct or improve it. Okay. Now 1 plus means 1 plus h because h is very small value. So let's substitute it, 1 plus h minus 1, and here h tends to 0. 1 minus 1, 0, and this comes out to h, limit h tending to 0. Again, it will be 0. So this is left hand limit and right hand limit are equal, means limit exists. But for continuity, we also have to check the value of function. What is the value of function? Here, as we are checking at x equals to 1, so f of 1 and 1 minus 1, it will become 0 simply. So here we have found out LHL, that is left hand limit and right hand limit, and the value of function. The value of function are equal and are equal to some finite value. That's why this function is continuous at x equals to 1. So this is an example of continuity at a point. At a point. So is this clear, everyone? Is this clear, everyone?
Yes, sir.
Great. So as we have talked about the continuity of function, let us talk about this continuous function. So a function which is not continuous at a point x equals to a in its domain is said to be discontinuous. That the point a is called a point of discontinuity of the function. So it is simple that wherever our graph is breaking, so we can call it as a discontinuous function. And if the graph is continuous, then it is a continuous function. Here is an example of inverse function 1 by x, because at x is equals to 0, function becomes 1 by 0, which is an indeterminate form. So the continuity does not exist at x is equals to a, as also the graph can suggest that these curves at x is equals to 0 is not meeting. It's not a there is a jump and there's no connect between those two curves of the same function. So that's why this function is discontinuous at x is equals to 0. Okay. And there is also one more point to note over here, that the function is a function which is not continuous at a point x is equals to a in its domain. So you have to consider that if a function is discontinuous, then if we are checking for the discontinuity of a function at a particular point, and that particular point must be in its domain, so that we can declare the function as discontinuous. Is that clear, everyone? Is that clear?
Yes, sir.
Okay. So there can be multiple conditions that discontinuity of a function can arise. As for continuity, our condition is left hand limit must be equal to right hand limit, and that should be equal to value of function. And it all is sum be equal to some finite value must come out of that. This is our condition for continuity. This is condition for continuity of fx at x equals to a. Now for this function to become discontinuous, is if there any of the condition will not satisfy, then we can say that this function is discontinuous. So there are some conditions given, like for in first, when limit does not exist, or both may not exist, then we can say the function is discontinuous. If the limit as well as if the right hand limit as well as the left hand limit may exist but are unequal, then we can say the function is discontinuous. If the right hand limit and as well as the left hand limit both may exist, but either of two or both may not be equal to value of function f of a, then we can declare the function as discontinuous. So is that clear, everyone? Is that clear, everyone?
Yes, sir.
Okay. Let's move ahead then. This is an example. And I want to know that how many of you have done your homework of yesterday?
Sir, I have done the homework, but I done the all problems in a wrong way, sir.
What? Could you repeat?
I done the homework, sir, but actually what happens is the homework which I done was actually the wrong answers. I all get the wrong answers, sir.
No problem. You can ask me the doubts at the later stage of this class. So we'll be taking doubts at 6:50. Okay.
Okay,
But
sir.
that's good. Yeah.
Sure.
Okay. So now let's discuss this example. The function is continuous at, there are certain points given. So whenever there is any doubt in the continuity of the function, then it may arise at at the point where the function's definition is changing. Whenever function's definition is changing, then it is most probable that the function will become discontinuous, right? If let's say if I'm saying that the function is sine x for x 0 to pi by 2, and the function will become as cos x for x belongs to pi by 2 to infinity. So now at this point where the function is breaking, anyone can you tell? Anyone? This function is breaking at x is equals to pi by 2 because the function is changing at x is equals to pi by 2. So it is most probable that function is going to be discontinuous at the point where it is changing. Okay. So as in the question given, the function is given changing at t is equals to pi by 2. So let us first check the B option. Okay. So first what we'll find left hand limit and right hand limit, and then we'll find the value of function. So for finding limits, uh, let's write it as t pi by 2 minus left hand limit cos t on pi by 2 minus t. Okay, and I'm not going to use techniques, I'm not going to use tricks whenever we are discussing concepts. For now, I'll just rely on basic methods. And whenever we will be solving PYQs, then we will be using short tricks and shortcuts and short methods as we have already built upon our basic concepts. Okay. So left hand limit we are discussing. Let's write it in more appropriate manner. Okay. So pi by 2 minus cos t pi by 2 minus t. So pi by 2 is pi by 2 minus h. So cos pi by 2 minus h. Pi by 2 minus t is what? Pi by 2 minus h. Limit is existing. Sorry, now we are applying limit on h because we have changed the variable. So cos pi by 2 minus h is what? Anyone? Cos pi by 2 minus x is what? Cos pi by 2 minus x is sin x. We are going to discuss this in trigonometry. So you can write it as sin h. And pi by 2 minus pi by 2 will cancel each other, and this minus will become plus. So as we have discussed earlier, we have discussed the formulas earlier. This is a formula and it will become 1. So the left hand limit is 1. Let's discuss about the right hand limit. Limit approaching pi by 2 from plus infinity cos t on pi by 2 minus t. Okay. So we can substitute pi by 2 plus with pi by 2 plus h. Okay. Cos pi by 2 plus h on pi by 2 minus t is placed pi by 2 plus h. Limit is existing on h is tending towards 0. So here we can see cos pi by 2 plus h. So it will be changing in the next quadrant, and as well as cos is negative in the second quadrant. So it is coming out to be minus sine h, and pi by 2 cancel pi by 2 minus plus, this will become minus h. Limit is existing on h, minus minus cancel. Again, it becomes the same formula and it comes out to be 1. So we have left hand limit equals to right hand limit. So we can also go ahead and check the value of function at what? Pi by 2. So it was given in the question that on pi by 2, the value of function, the function itself becomes equals to 1. So the value of function is 1, whereas left hand limit is also 1, right hand limit is also 1. So we can say the function is continuous. Continuous at t is equals to pi by 2. So the question says the function is continuous at t is equals to pi by 2. B answer is correct. Any doubt, anyone? Any doubt?
No, sir.
Okay, so let's proceed further with our next example. Yes, there is. So in this function, the question is changed. We have to find the function's discontinuity point. So as we earlier discussed, that it is most probable the function will be breaking and there will be chances of discontinuity where the function will be changing. So let us first discuss that point where the function is changing. Can anyone tell that where the function is changing here? Anyone? On what point should we check about the discontinuity of this function?
Sir, I can't see your screen, sir.
Okay, let me. I'm sharing my screen, but is it visible
Yeah,
now?
right now it is visible, sir. Yes, sir.
Oh.
Yes, sir. It is visible.
No problem. So now tell me key on what point we have to check about the discontinuity of this function. At what point this function is changing? Okay, so let me first explain the question to you. So here it is a function given. Okay, the function when the function is whenever the function is x is equals to 0, so the value of function becomes 0. Okay, and whenever we are talking about the function at any point except when x is not equals to 0, so the functions so the function becomes this. So basically this is a condition that whenever x is equals to 0, we have function equal to 0. And when x is not equals to 0, then the function is like this expression. Okay. Let me see if I because my laptop is hanging. So in this kind of questions where there is a curly bracket in front of the equal sign, then it is saying to us that the function is having different forms when in different conditions. Here the condition is that when we are discussing about the function on x is equals to 0, so the function will be equal to 0. And when x will not be equal to 0 means let's say this is a number line. Let's say this is a number line, okay? And when this is minus infinity, this is plus infinity. So on this origin, 0, the function will become as it is given. Otherwise, we will take all the points except 0. The function will become to e1 by x minus 1, e1 plus x plus 1. So now anyone of you can tell me that where the function is changing? Anyone? Anyone? Can you tell me where the function is changing?
Sir, is it is between +1 to -1, sir?
No, it is changing on x is equals to 0. Because as I have told earlier, that whenever we live in, like on whichever point the condition of the function is given, and we are having different function on the, like for x is equals to 0, we are having function is equals to 0, and other than that we are having different function. So it is very clear that whenever we are traveling on points on the number line from -infinity to +infinity, the function will be changing on 0. So the changing and the critical point will be 0. So it is better to discuss about the continuity or discontinuity of that function on that particular point. Is this point clear to everyone? If not, I will repeat.
Sir, don't mind, can you please repeat it, sir?
For sure, for sure. Like first, let us understand what the question says. So let us consider this is a number line. Okay. So starting from -infinity, this is going to +infinity. So it is given in the question that whenever we will be, what is a function? Okay, what is a function? Here we are inputting something, and the function will give us some output. It is like a machine, right? We will give some input, and then it will provide some output. So here the input is the variable x, and whenever we'll be inputting the x from on, like say number line, on a number line for or n number line, for say -100 to -99, -98, -97, -96. So that number would be inputted in this function which is given to us. So this is a function, and whenever we have to input any value of x of the input, then we are going to use this function. We will be directly applying or putting those values. Let's say for x is equals to -100, we'll be substituting x with -100, and there will be some output, and that will be the output of the function. But if we change the input, we change the variable x to 0, then we will not consider this function. We will consider we have a different function which is directly given as a 0. Otherwise, it would have also written x, then the value function would have come the same because the x is equals to 0. So, okay. So I'm not going to complicate things for you. It is simple that the function is this particular expression, but only when we are putting x is equals to 0, we are having a different function, and that particular function will be 0. Okay, that is simple. It is as simple as that. So we can input any value of x from -infinity to +infinity. But when it comes to x is equals to 0, we have a different function. We have a different form of function in that particular function. So is this point clear to everyone? Everyone, please.
Yes, sir.
Yes.
Yes, sir.
Yes. I would request everyone to unmute themselves and respond to learn if you truly want to learn. And please don't be shy. No doubts. Everything is clear. So I'm now going to ask everyone, and except then Raja Krishna Gade, that on what point this particular function is changing its form.
Sir, x equal to 0.
Yes, Nandana. Your voice is not coming.
Sir, could you hear me, sir?
Your voice is so mellow. Try speaking louder or rejoining maybe.
Sir, could you hear me?
Yes, try.
Sir, x equals to 0.
Yes, absolutely right. So I guess you understood about that how function is changing and what this particular question is trying to say. So let's now proceed. Okay, I'm going to use this diode. Okay. So now let us proceed and discuss this question further. As we will be finding left hand limit and right hand limit for x is equals to 0. But when, as you know, when we find left hand limit, so we actually are finding for the value of 0 minus h, which is not 0, but slightly less than 0. So when it is not equals to 0, so to which function we have to apply the limits? Please unmute yourself and speak. As we have to apply the limit on a function for the value of x which is not equals to 0, which is slightly less than 0, this is not 0. So which form of function should we refer to?
Sir, it is like in improper like I couldn't say the name, sir, but it is like indeterminate form. I think so.
Okay, I'm asking you more in a more simple manner that we have to apply, we have to find out left hand limit and right hand limit for this function. Okay, and now is that we have to apply the operation of limit on this function and on that for that point which is not 0 but slightly less than 0. Okay, for left hand limit, and for right hand limit it is slightly more than 0. Okay, so for which form of function out of these two, 0 or this particular function, that we have to use to apply these limits? This is my question. Will it be 0 or will it be e raised to power 1 minus x wala form?
Sir, it is e power x.
Why so?
E power 1 by x minus 1, sir.
Why?
Sir, because if you kept the 0, the function will become the 0 and it will be changing.
Okay. Satisfactory answer. So let us now proceed and find left hand limit and right hand limit. For finding left hand limit, we are approaching the function from 0 minus e1 by x minus 1 e1 by x plus 1. 0 minus says like we can write it as 0 minus h minus 1 e raised to power 0 minus h plus 1 limit h tends to 0. I hope you are able to understand what I have written here. I have just written 0 minus h at the place of x. So it will simply become e raised to power minus 1 by h, because we can write the minus sign in the denominator or the numerator, it is the same. Okay. So as we know, any exponential can having power of negative. Okay. So we can write it as 1 by a raised to power x. Are you aware about this, everyone? So we can simply write it as 1 by e raised to power 1 minus h minus 1. And same goes for this. Sorry. let's take LCM, which will be e raised to power 1 minus h, 1 minus e raised to power 1 minus h, 1 plus e raised to power 1 by h, e raised to power 1 by h. Limit is 1, tends to 0. Okay. So as we can see here in the question, that this and this will be cancelled. Are you able to understand that why these will be cancelled? If you have any doubt, then you may unmute yourself and ask. So we have written it just on the next page as the other two terms, other two terms here were cancelled. So now what we can recall is that our property where we have discussed about like 1 ex by x, limit x extends to 0 is equals to 1, right? And actually it was like different. So let me write you what form I have told you. So this form we have discussed in the formulas, okay? And when we will multiply the numerator by minus, it will be the same. You can also remind it as using the same form which we have discussed in the written formulas. So let us multiply it by minus 1, the numerator, e1 by h minus 1, e1 by h plus 1, limit s tends to 0, and minus 1 as we have multiplied it with. So minus 1 will make it plus 1. So I was confirming the formula. Yes, this formula is correct. So what we have to do now is in this particular form, there was an x down in the denominator, but here we do not have one. So we will artificially and we will ourselves make it. Like we will bring 1 by h in the denominator also. So for that, let's write it as 1 minus h by 1 by h. As we have divided by some term, then if we will multiply it with the same term, then it will neutralize the effect, right? It will cut itself. So we have remaining term tends to 0. So here, if we will see this, this particular expression is the formula, and it will be 1. So when 1 will be multiplied with any other term, it will come out to be similar. Same. Okay. Now, as we can see in the expression, if we will substitute h with 0, then the numerator will come out to be 0 and e raised to power, sorry, the numerator will come out to be e raised infinity, because 1 by 0 is infinity. E raised to power infinity plus 1. This will be also infinity by infinity, which is an indeterminate form. So we can use our best friend, which is L'Hospital rule here to solve this particular problem. So what was L'Hospital rule? Is that we have to differentiate the numerator and denominator. So differentiating them. 1 by h is what? Differentiation of 1 by x. Like 1 by x differentiation. Anyone aware about this formula? Anyone? Minus 1 and minus 2 minus 1 x squared. Am I correct? Am I correct? Minus 1 by x square. Denominator. Differentiation of this e raised to power anything e raised to power x differentiation is same. And multiplied with whatever differentiation of the power it has. The differentiation of 1 with respect to h is 0 itself. So if we are multiplying it with the same derivative, it will get cancelled and it will come out to be numerator is 1, denominator is 1 by h. Now we can like substitute h for 0 and it will come out to be e raised to power 1 by 0 become infinity. So 1 by infinity, which is say 0. Okay. Now we have to find the right hand limit. Finding right hand limit. Watch our function was this, I guess. No. Let's see, our function was e raised to power 1 by x minus 1. We are approaching x1 from right hand side from plus infinity. Okay, so 1 plus is 1 plus, sorry, 0 plus h. Yes, it is 0. We are checking for 0. So 0 plus is 0 plus h. Okay. X is approaching 0 from plus infinity, and 0 plus is 0 plus h. Now substitute 0 plus h minus 1 e upon 0 plus h plus 1. Limit h tends to 0. Is my handwriting legible to you all? Everyone? Please respond. Okay. So now we are going to apply the same method in which that we have to make 1 by h in the denominator too. So we will multiply in the numerator and come out to be this. Limit x tends to 0. This is the formula which will make it as 1. The formula is written here. So going further, limit s tends to 0, 1 by h, e raised to power 1 by h. Applying L'Hospital rule. First of all, substituting, this will become 1 by 0 become infinity, and e raised to power infinity plus 1, it will become infinity by infinity. So this is an indeterminate form, so we can differentiate our function, which is this. So differentiating the numerator will make it minus 1 by x square. Then differentiation of the denominator, this particular term will comes out to be the same. The different multiplied by the differentiation of 1 by x, 1 minus x square. The differentiation of 1 with respect to h will be 0 because it is a constant. Now this and this will get cancelled, and we can directly substitute the value of h here. So it will come out to be e 1 by 0, and 1 by 0 is infinity. 1 by infinity is 0. Okay. So 1 by 0 is infinity. E raised to power infinity will be infinity, and this is 0. So left hand limit is equals to right hand limit. Now let us check on the value function on f of 0. So on f of 0, this function is coming equals to 0. Okay. So yes, f of 0 is also 0. So here we have LHL, RHL equals f of 0 equals to 0. So most probably this function is not is continuous at f of 0. So let us check that have we made any mistake while solving this question? Because I'm feeling so that there is a mistake we are doing. Everyone be attentive. Okay. So this is the right step. Then we have substituted it. So e plus minus 1 by h, e1 by h, e1 by h plus 1 minus e to the power yes. Yes. This is a correct step. We have taken LCM. We also taken LCM here. These two both cancelled. In next step, what we have done, changed it side by multiplying it with -1. Okay. So when we multiplied it with -1, we solve this further, but we didn't multiply it here with -1. Here will also come by -1. Here it will become positive. Then moving on, has it become positive? So the minus and minus will not get cancelled. There will be a -1. Okay. There will be -1 here. And this will equals to 1 minus 1 by e raised to power infinity. And 1 by infinity, which is 0. And 0 into -1 will itself make it 0. So I guess it's correct. Yes, anyone, can anyone spot any other error? Please unmute yourself and speak. Let us look on the next slide. E1 by x minus 1, E1 by x plus 1. And then we have substituted it with h, 1 by h, 1 by h. And then we have applied the formula 1 by h. Okay, it is 7:04 p.m. Wait a minute. Okay, it is 7:04 p.m. Anyways, I guess because I do not guess, I know the answer. This function is going to be discontinuous at x is equals to 0. In the book, as per the book, it can also be a case that the book have solved it in a wrong way. So we will discuss this question later because for now, I am not sure about its answer. So this is a calculation. It may be a calculation error. It may be a calculation error in the book. I didn't know about it. So please do not take any inspiration from this question, particular question. Let's drop it. Okay. Let's drop this. We'll discuss it tomorrow. So we have talked about continuity of a function. If you have any other doubts, one person who's having some doubts, please shoot here and we will discuss it in a faster manner. Yes, Raja Krishna Gade, you were having some doubts. And if anyone else also have some other doubts, please shoot. Waiting. So let me take your attendance for today. Tanish was also there in the class, right? Please unmute yourself here, everyone. Okay, so I guess there is no doubts. If you have any further doubts, please send it on WhatsApp group. I'll answer them whenever I give time, okay? So any reviews or feedback for today's class? Was it too fast? Was it too slow? Please.
Sir, no, sir, it's good. But I would like to say something that
Yeah.
your handwriting is fine. Just don't worry about it.
Okay, thanks. Okay, great. So let's conclude today's session. Thank you everyone for your attention, and please be more interactive while in class. And Nandana, you can improve your mic. Your voice is very low, so I have to get closer to my laptop to listen. Okay.
Sure, sir.
Okay. Thanks everyone. Good evening, Jai Hind, and you can interact with me in WhatsApp anytime. Okay. Jai Hind.